Alright, 10th standard, welcome back. This is the third part of the video for exercise 15.1. We have done till 18th question and now we are going to do the remaining questions of 15.1. Let's take up question number 19th. So question number 19th is, a child has a die whose faces are marked with letters. Usually the die we play with is marked with numbers. The die that the child has is showing some letters. So A, B, C, D, E, then A. Now clearly you can see this is a biased die. Biased die because there are two faces marked with same letter. The die is thrown once. Consider this a normal question, like a normal die would be thrown, the one which contains 6 numbers, 1, 2, 3, 4, 5, 6, just like that. So here we have some letters. The die is thrown. What is the probability of getting A? So there are 6 possibilities, out of which in favor of A there are 2. So the probability will be 2 by 6. This can be done orally. Then second part, the probability of getting D. So there is just one face which has D on it. So out of 6, 1 is in the favor of D. So probability of getting A is 2 by 6. Probability of getting D is 1 by 6. 20th question. Suppose you drop a die at a random on the rectangular region shown in this figure. So there is this figure given. It's a rectangle with dimensions 3 meters by 2 meters. A die is thrown in this region. What is the probability that it will land inside the circle with diameter 1 meters? So this circle has diameter 1 meters. You want to find out what is the probability that the die will fall or land inside this circle. So when we are talking about the inside of the circle, we are talking about the region. And for the region, we consider the area. So this surface inside the circle is the area where we want the die to land. To find out the probability that the die will land inside the circle, we will consider the area of the two shapes. So total possibility is that the die could fall anywhere in this rectangle. So the area of this rectangle is the total possible outcome. That will be in the denominator. Then what is in the favor of our question? We want the die to land inside the circle. So the die lands inside the circle means the die lands inside this circle, this area. This area is area of the circle. This is what is in our favor. So the probability will be given by area of the circle over the total area available, which is the area of rectangle. Let's write down. So this is what we have. This is 3 meters by 2 meters. There is a circle inside. If this is the center, the diameter is 1 meter. And we want the die to land inside the circle. So probability, you can write down required probability if you don't want to write down the complete statement. Required probability will be given by area of circle. This is the favorable thing which we want to happen. And area of a rectangle, this is something that can happen. This complete area, the die could land anywhere. So area of circle is given by pi r square and the area of rectangle is given by length into breadth. Use the values. Length is 3, breadth is 2. The units are meters. Diameter of the circle is 1 meters. Therefore radius will be equal to 1 by 2 meters. Using the values, pi 1 by 2 square in the denominator, 3 into 2. So this is pi into 1 by 4 into 1 by 6. So this comes out to be pi by 24. If you want, you can use the value of pi and give the answer in the simplified form, or you can just leave it like this, and that's completely fine. Let's take a look at 21st question. A lot consists of 144 ball pens, of which 20 are defective and the others are good. We have done a question similar to this, the one with the bulbs. Total number of pens is given. Defective pens are 20. Remaining will be the good pens. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? So she will buy it if the pen is good. And what is the probability that the pen is good? Find the number of good pens over total number of pens, and that will give you the probability that Noori buys the pen. Second case, she will not buy it. Noori will not buy the pen if the pen is defective. So probability that she does not buy the pen depends on the probability of getting a defective pen. And what is the probability of getting a defective pen? Number of defective pens over total number of pens. Let's write down. Question number 21st. You can write down first of all the statement. So total pens, it's 144. Defective pens is 20. So good pens, subtract, this is what you get. And now the first case, probability that Noori buys the pen, it is equal to probability of getting a good pen. She will buy the pen only if the pen is a good pen. So for the probability of a good pen, number of good pens over total number of pens. Similarly, for the second part, Noori doesn't buy the pen. This depends on the probability of the pen being defective. And how many defective pens are there? There are 20 defective pens out of 144 pens. Now let's take a look at question number 22. Question number 22, they are saying refer to example number 13. So example number 13, and then what you have to do is you have to complete the table. If I look at the table, it says event is the sum of two dice, sum on two dice, and then probability for these. Let's go to example number 13 and let's see what the example is. This is example number 13. Two dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes. So when they ask you to write down all the possible outcomes, this means they are asking for the sample space. What is the probability that the sum of the numbers appearing on top of the dice is 8, 13, less than or equal to 12? So when the dice are rolled, they will show a number on the top. Since there are two dice, there will be one number on the first die and one number on the second die. We will be looking at the sum of those numbers and then see how many cases are in favor of giving us a sum equal to 8, how many cases or outcomes give us a sum 13, and how many outcomes give us a sum equal to 12 or less than 12. Before we answer this question and we go back to exercise 15.1, let's write down the sample space when two dice are rolled. Irrespective of the color, let's write down. So question number 22, for this we are considering example 13. It's on page number 306, and in this example two dice are thrown at the same time. So at the same time means simultaneously, or you can say the dice are thrown together. They want us to write down all the possible outcomes. Now the possible outcomes will be written by combinations of the numbers that can be formed. So imagine the first die shows 1. Let's keep that fixed. And on the other hand, the numbers on the second dice or the die could be any of the 6 numbers. So you could do this by making a table. So let's divide it like this. On first die, So on the first die we could have 1, we could have 2, we could have 3, 4, 5 or 6. This is for the first die. And then for the second die, on second die we could have 1, we could have 2, we could have 3, 4, 5 and 6. Now the combinations will be formed by these. If we have 1 on the first die, there could be 1 on the second die. So the combination of these two will be written as an ordered pair. 1 on the first, 1 on the second. Then we still have a 1 on the first die. So ignore this. We have 1 on the first die and we have 2 on the second die. So this will be 1, 2. Then we have 1 on the first die with 3 on the second one. Then fourth possibility, there is 1 on the first die and 4 on the second one. So this way you could write down all the possible outcomes. Now for 2, if on the first die you get a 2, combine it with all 6 possible outcomes. So 2 will have a combination with 1. This 2 will have a combination with 2. This is like combining columns and rows, and you have intersection. So this is these are the rows and these are the columns, and their intersection, the cell formed, you have to write down its number, if you can think of it that way, like a spreadsheet. So this is 2 with 3, then 2 with 4, 2, 5, 2 with 6, making combinations with third number 3 and 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. So 4, 1, I'll just quickly write this and we'll continue. So I have written all the possible outcomes. Because we were doing it for the first time, so I have made this table. You could directly write these outcomes in curly brackets by denoting it with S and inside curly brackets. So this is how you'll be listing, this way: 1, 1, 1, 2, so on up to the last one. Now you can note down one fact here. The outcomes in which the numbers on the two dice are exactly same. So this one, 1, 1, 1 on the first, 1 on second. 2, 2, same number on both. 3, 3, same number on both. These are called doublets. These are called doublets. Now, if we look at this table and we want to know the probability that the sum is 8. So I'm still discussing the example. Probability that sum is 8. Sum of numbers on the top. So if we look at the sum formed in each of these cases, the sum of this outcome is 2. The sum of this outcome is 3. Sum of this outcome is 4. So on, you have to look for those outcomes in which the sum is 8. Let's mark those. I'm going to mark those in red. Sum is 8. So I have got 2, 6, sum is 8, 5 and 3, 4 and 4, 3, 5, 5, 3, then 6, 2, that's it. So there are 6 cases, there are 1, 2, 3, 4, 5 outcomes in which the sum formed is 8. And how many total outcomes are there? So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 into 6. Total outcomes are 36. And for 8, there are 5 outcomes. So the probability is 5 by 6. The second part is we want the probability of getting the sum as 13. So probability that sum is equal to 13. Let's take a look. The minimum sum that you can obtain here is this. The smallest numbers on both dice. the sum is 2. The minimum possibility is that the sum will be 2. And if we get the largest numbers on both, 6 on the first one, 6 on the second one, then the sum is 12. There is no sum beyond 12. So you can get a sum from 2 up to 12. And we want the sum to be 13, so there is no such case. So this is an impossible outcome here. Impossible event, sorry. Now let's look at the third part. Third part is sum is less than or equal to 12. So the sum is less than 12. If you start looking at each of these, here the sum is 2 less than 12, sum is 3 less than 12, sum is 4 less than 12, 5 total is 5, which is less than 12. If you keep counting till you reach here, except for this one, in all the cases the sum is less than 12, and in this one the sum is equal to 12. So that means all the outcomes will be in favor of this event. So if all the outcomes are in favor of an event, that means that event is a sure event. The probability will be 1. You could write 1 directly, or you can write this way, that out of 36 outcomes, all 36 outcomes are in favor of this event. 35 have a sum less than 12, and the 36th one, the last outcome, has a sum equal to 12. So this is a sure event. And this one is impossible event. Now let us go back to the question that we were doing. So we were doing 22nd question. What they are saying is they are asking you to refer to the example number 13 and complete the table. In the table, they have mentioned what are the possibilities of the sum obtained. As I told you, the minimum sum that you can obtain is by getting the minimum numbers on each die. So minimum numbers on each die will be 1. 1 on the first die, 1 on the second one. In that case, the sum will be 2. So the minimum sum that you will get is 2. And the maximum sum that you will get is when you have the largest numbers on both dice, means 6 and 6. In that case, the sum will be 12. So these are the possible values ranging from 2 up to 12. Now you have to write down the probability for getting these sums. If you have done example number 13, you would know how to fill this up. We did in the last example, the sum 8. The probability was 5 by 36. So I have the answer with me right here if you want to take a look. So we calculated the probability that the sum is 8 is 5 by 36, and they've already filled it here. The probability that the sum will be 2. So there is only one case, first one, where we have 1 on both dice. So this one has sum 2. So one outcome out of 36 outcomes will give me a total 2. That's why the probability is 1 out of 36. And the sum 12. Now to obtain the sum 12, I need 6 on both dice. And there is only one outcome. So there is only one outcome out of 36 outcomes, which gives me a total of 12. That's why the probability is 1 by 36. So this way, if the sum is to be 3, how many outcomes are there? That will give me a sum 3. So this one and this one. The sum is 3 in this case. So how many outcomes are in favor? 2. 2 outcomes. So here the probability will be 2 out of 36. And then further we want that the sum should be 4. The sum should be 4. Let's take a look again. The sum should be 4. How many outcomes are in favor of getting a sum 4? So the sum 4 will be obtained by these outcomes. 3 plus 1, 2 plus 2, 1 plus 3. So 3 outcomes will give me sum 4. So the probability in this case will be 3 over 36. So same way you can complete the table, and once you have done that, we will move on to second part. So I'll quickly fill that up, and then we will do the next part. So I have filled it up. You can use that sample space to fill this table. Now let us talk about second part of this question. Again, it's a theoretical question. A student argues that there are 11 possible outcomes. If we just look at this table, the table has been listed with these outcomes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 possible sums that we can obtain. So this is what he is saying, that there are 11 possible outcomes: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability 1 by 11. Now, if he says that all of these 11 outcomes have same probability, 1 by 11, he means that all of these outcomes are equally likely. That's why they have same probability. But is it so? It is not so, because these outcomes do not have the same probability. And how do we know that? We already calculated the probabilities in the first part. If we look at the probability of getting a sum 2, there is 1 by 36. The probability is 1 by 36. Now look at the probability of getting 3 as the sum, 2 by 36. Probability of getting 4 as the sum, 3 by 36. So all these 11 outcomes do not have equal probabilities. That's why they are not equally likely outcomes, and that's why the student is incorrect. So we don't agree with this statement. He is wrong to consider these outcomes as equally likely. Now moving on, question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. So I have discussed with you, when a coin is tossed 3 times, or 3 coins are tossed together, the sample space is same. We are going to write down the sample space for this before we do the question. Let's read the remaining part. Hanif wins if all tosses give the same result. So in 3 tosses, if he gets heads, 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 or if he gets tails, 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 that is when he wins. In any other case, he loses. Calculate the probability that Hanif will lose the game. Alright, let's write down the sample space when 1 coin is tossed 3 times. So the first thing we want to know is, if n is used to write down the number of coins, or how many times 1 coin is tossed, then total number of outcomes are given by 2 raised to the power n. So this is something you want to remember. If we use n to represent the number of coins being tossed together, or n represents how many coins a single coin has been tossed, how many times a single coin has been tossed, then if we want to know how many possible outcomes will be there, the answer will be given by 2 raised to the power n. And we want to know how many outcomes will be there before we actually start to list those outcomes. So in this case, a coin is tossed 3 times. Therefore, n is equal to 3, which means total number of outcomes. We need the total number of outcomes to write down the probability. 2 raised to the power n, which is 3. So this will be 8. Now to list the outcomes, I'm going to make a table. You could make it in rough work or you could make it in fair work. I have made 3 columns. This is for the first toss, this is for the second toss, and this is for the third toss. So what I want to do is, I will start with the total number of outcomes, divide it into half. So either heads can come or tails can come. When a coin is tossed, either I will get heads or I will get tails. Now there are 8 outcomes in all, out of which half will be heads, half will be tails. So I have got half of 8, 4 times H and 4 times tails. So 1, 2, 3, 4 heads, 1, 2, 3, 4 tails. From the total, half for the first toss. Now moving on, divide 4 into half again. So 4 heads divided into 2, 2 heads, 2 tails, 2 heads and 2 tails. But overall again there are 4 heads, 4 tails. Now for the third toss, from 8 we have written 4, 4, then we wrote 2, 2. Now we will write 1, 1. So 1 heads, 1 tail, 1 heads, 1 tail, 1 heads, 1 tail, 1 heads, 1 tail. And again, if you look at the overall column, there are 4 heads and 4 tails. Based on this, let's write down the sample space. This is the first outcome. First time heads, second time heads, third time heads. So to write down the outcomes for the tosses, we will put them together, H, H, H. And then for the second toss, we have, for the second outcome, we got heads, heads and tails. So H, H, T, then H, T, H, H, T, T, then T, H, H, THT, TTH, TTT. This is one way to write down the sample space. Then there is another shortcut if you forget this. Now this works for every possibility when you know the number of tosses performed on a single coin, or you know how many coins have been tossed together. Now the shortcut that I'm going to show is it works for writing down the sample space for this case when a coin is tossed 3 times or 3 coins are tossed together. And for this you should know what is the sample space for when 2 coins are tossed together. So if 2 coins were there or a coin was tossed twice, the sample space would be HH, HT, TH, TT. Now what you want to do is you want to use H and T with each of these. So use H and T with this, H and T with this, H and T with this, and H and T with this. So you get H, 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 T, then using H, T and H, H, T, H, H, T with T, then TH with these two, TH with H, TH with T, then TT with these two, TT with H, TT with T. So this is a shortcut that you could use. I would suggest that you work with this one because this helps in any case if you are given the number of coins tossed. Based on your sample space, let's write down what is the probability that Hanif loses the game. So probability that Hanif loses the game. So Hanif wins if he gets same result all 3 times. So this is the case when he gets the same result in 3 tosses, and this is the result in which gets the same result. So this is a winning situation, this is a winning situation. We want the situation when he loses. So out of 8, 2 outcomes will make him win and the remaining 6 will make him lose. So 6 out of 8 outcomes are against him. Now let's take up question number 24th. Die is thrown twice. Now a die is thrown twice or 2 dice are thrown simultaneously. They are treated as the same experiment, just like coins. A coin being thrown twice or 2 coins thrown together. So we already have the sample space written for this. I'll use the same result. I'll use the same table. What is the probability that 5 will not come up either time? So what you're looking for is, you don't want to see 5 on any of the dice. 5 will not come up either time. 5 should not be there. So how many outcomes are there without 5? So for doing this, let's delete the outcomes which have 5 on it. So if we want to delete the outcomes which have 5 on it, so let's do that. So this outcome contains 5. So delete this. This contains 5. This complete column will be deleted. And then this row will be deleted. These contain 5 and these contain 5. How many are we left with? We didn't want 5, so we have deleted the outcomes in which we got 5 on one of the dice. So the remaining outcomes. So let us see how many we deleted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 36 outcomes, I have deleted 11 outcomes. Remaining are in my favor. So that means the probability for this case will be 36 minus 11 on top, that is 25, and in the denominator I will have 36. So probability 5 will not show up on either dice. This is 25 out of 36. And then in the second case, 5 will come up at least once. So at least once, and in this case, so either one time or two times. So these were the cases in which 5 appeared, and this one in the middle had 5 appearing twice. So these are the ones which we need for the second part. So probability 5 will show up at least once. This is 11 over 36. Now let's take a look at the last question. Question number 25th. Which of the following arguments are correct, which are not correct? Give reasons for your answer. First part, if two coins are tossed simultaneously, there are 3 possible outcomes. 2 heads, 2 tails, or 1 of each. Now, is that true? We have written the outcomes when 2 coins are tossed simultaneously. I will quickly write down the sample space when 2 coins are tossed. So when 2 coins are tossed, the sample space has HH, HT, TH, and TT. These are the possible outcomes. Now what they are saying is there are 3 possible outcomes. So there are not 3 outcomes. This is wrong. We don't have to even look further. But the way they have described is kind of correct. But saying that 3 outcomes is wrong. The description is correct, the way he describes, the way the statement has been written, that you will either get 2 tails. So sorry, you will get 2 heads. So this is one case. Then you get 2 tails. So there's this case, and then you get 1 of each. So either there'll be 1 heads, 1 tails, and these 2 outcomes are in this favor, 1 of each. But this does not mean that there are 3 outcomes, because getting 2 heads, 1 outcome, getting 2 tails, 1 outcome, but getting 1 of each is not a single outcome. There are 2 outcomes in this favor. And hence, further when they say for each of these outcomes the probability is 1/3, they are wrong. Probability of getting 2 heads. So probability of getting 2 heads, 1 out of 4. Probability of getting 2 tails, 1 out of 4. Probability of getting 1 of each. You need 1 heads and 1 tails. So there will be 2 out of 4. The probability is not 1/3. So this statement is false or incorrect. Now let's consider the second part. If a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1/2. This is kind of correct if we list the outcomes. If we list the outcomes for this experiment, The sample space is this 1 2 3 4 5 6, and what we want to know is, we want to know what is the probability of getting odd number. So total 6 outcomes can be divided into 2 categories. So we have even number, so this is odd, this is odd, this is odd, and 2 4 6 are even. Broadly looking at these 6 outcomes, we can say that either the number will be odd or the number will be even. We could say that. But further, when we look at this statement, they are saying that the probability of getting an odd number is 1 by 2. Let's see probability of getting even number and probability of getting odd number. So there are 3 odd and 3 even numbers. So the probability for these will be 3 by 6, 3 by 6. So this is 1 by 2, this is 1 by 2. Even if you don't simplify, looking at the probability, you can tell, since the probability of getting even number and odd number is equal, these are equally likely outcomes. And when the outcomes are equally likely, their probabilities are equal. So there are 2 results with same probability, and hence they have 50-50% chance of happening, and 50-50% chance means half chance. So the probability for each of these is 1 by 2, 1 by 2. So that completes your exercise 15.1. In the next video we will discuss exercise 15.2.